To begin our probability tree, we're going to start with our dot, and this is going to be our root. Now our next step is to put the branches from the root here. So our two options we have, the person is either left-handed or right-handed. The probability that they're left-handed is 10%, and the probability they're right-handed therefore would be 90% due to the complement rule. So that's our first student, our first set of branches. Now our next set of branches, based on the first student, the second student could be either left or right-handed. And if the first student was right-handed, the second student could also be left or right-handed. And our probability with our left-handed is still 10%. These events are independent. 10% and 90%. Now our last step is to go through, because we only have two students, so we're done with two sets of branches. We're going to do our joint probabilities. So the probability that the first student and the second student are left-handed is 0.1 times 0.1. The probability that our first student is left-handed and our second student is right-handed is 0.1 times 0.9. Probability that our first student is right-handed and our second student is left-handed is 0.9 times 0.1. Probability that both students are right-handed is 0.9 times 0.9. Now we want to fill in our joint probabilities because we should check these to make sure they add up to be 1. So the probability that they're both left-handed is 0.01. The probability that I have left and right is 0.09, and that'll be the same for both of these branches. And then the probability that they're both right-handed is 0.81. And when we add these up, they come out to be 1.00. And that is the probability tree for two students selected at random.